Hi everyone, welcome to YR Digital YouTube channel, Python tutorials. My name is Srinivas. In this session, I am going to discuss about set operations in Python. Set operations. Set operations in Python. Set operations in Python. So, what is set? What is set? What is set? Set means a collection of values. Set means a group of values. A collection of values. A collection of values. A collection of values. Each value is separated by commas. Each value separated by commas and enclosed by curly braces. Curly braces. It is called a set. What is set? A collection of values. Each value is separated by commas and enclosed by curly braces. It is called as a set. Indirectly, it is unordered list. It is also called as a unordered list. Okay, up to here clear all of you. Now set operations, set mathematical operations, What is it? In general, set means S1, it is a set one, In general, it is a S1 is a set one, S2 is a set 2, S2 is a set 2. This common point is called as intersection, and that this point is called as a S1 minus S2, and this point is called as S2 minus S1, and the entire part is called as a S1 union S2. These are the set operations indirectly. And now here the set operations are there are different set mathematical operations. First one is set union, and second one is set intersection operation. Third one is set difference. Fourth one is set symmetric difference. These are the symmetrical mathematical operations in sets. The first one is set union. First of all, what is set union? Union. This is done by using the union function. Union is an inbuilt function or type symbol. This is a union operation is done by two union function or the type symbol. This function, this operator, it returns. Okay. The elements present in both the sets. This function returns the elements present in both the sets. For example, what is the set? For example, here S1 is S1 equal to one value. S1 equal to, for example, 11, 22, 33, and 44 is the S1. And S2 is also another set. For example, these are the operations 33, 44, 55, 66. These are the elements. Now here, what is S1? S1, this is S1. Okay. And this is S2. This is S2. S1 and S2. For example, this is a S1. This is S1 set, and this is S2 set. This is a S2 set. Here the elements are 11, 22. Okay, 33 and 44. Because 33 and 44 are also present in the set 2 also. Another element 55 and 66. Here, what is union operation? It is the elements present in both the sets. Both the sets means the elements are present in both the sets 11, 22, 33, 44, 55, and 66. It is a set. Now print of S1 by using operation type symbol S1 and S2. What is the program? Run the program. The value is this is a syntax invalid syntax operations. Please wait 1 minute. This is explaining the theoretical part. Up to here, these are up to here separated by comments. After run the example. Here is the example. Okay. Here is the example. Okay. These are the set operations There are the set operations, mathematical operations on set and run the program. The output is 33, 66, 11, 44, 22, and 51. Because set is a unordered list. It is a list of values, enclosed by the curly braces, and these elements are present in the given set unordered, but not the order. List elements are present in the ordered, but the set elements are present in the unordered. Okay, up to here, clear all of you. Okay, next go to the second point, and the second point is, and the second function is set intersection. Set intersection. This operation is done by intersection function or ampersand symbol both are same. It returns the common elements. What is the intersection operator? Intersection operation. It is the common element. This function or this operator is a common element. Okay, present in both the sets. Common elements present in both the sets. For example, S1 equal to on set 11, 22, 33, and 44. S1. S2 equal to 33, 44, 55, 66. Example. Okay, here the elements is S1 value 11, 22, 33, 44. S2 value 33, 44, and 55. Here S1 value is 11. 11 is present in the S2 or not? No, not presented. And 22 are present in not one? S2? Not presented. 33 is present in S1 and 33 is present in S2 also. That 33 is a common element. And 44 is present in S1 and 44 is present in S2, and the 44 is a common element. The picture like this shows like this. This is a S1, and this is for S2. This is for S2. Sorry. Okay, this is for S1, and this is for S2. Here 11, 22. The common elements are 34 and 44, and these are another elements are 55 and 66. The intersection operation returns these elements only. Print off S1 ampersand S2. S1 ampersand S2. Or okay, first of all, run this program. These statements are enclosed in the comment symbol. Okay, S1 and S2. This is only for program. S1 is the first set, S2 is the second set, and print the intersection element. The intersection element run the program. Only the intersection elements are 33 and 44. The output displayed in the bottom of the screen. Please observe it. The output displayed on the bottom of the screen. The output is 33 and 44. These elements are common elements. These elements are common elements in both the sets, like this. Clear up here, all of you. Right. The next one, third one is set difference. This is very important. Set difference, like this minus operation. Now this concept, set difference or minus. Okay, it returns elements present in first set. And but not in second set. For example, here is a S1 is a one set, 11, 22, 33, and 44. Okay, and S2 is another set. Elements are 33, 44, 55, and 66. The second set, right? Okay, here the first set here. Here the first set is set 1, S1. Okay, set 2 is S2. S1 elements are 11 and 22. S2 elements are 55 and 66. Here the elements are 33. Common elements are 33 and 44. What is the rule? It returns the elements present in first set, but not in the second set. The elements are present in first set is 11 and 22 only, but not in the second set 33 and 44. So this here we are writing print of. Here we are writing a common statement print of S1 minus S2 are using difference function. So both are same. S1 and let's run the example. And the example S1 is a value. 30, 44. S2 is another set of values. S1 minus S2 and the program. The elements are present in first set, but not in the second set. Here, the output is 11, 22. The output is 11 and 22. The elements are present in only first set. The first elements are 11, 22, but not in the second set. 33 and 44 are also available in first set, but these elements are present in the second set also. Okay, clear up to here, all of you. And next, go to another function, that is the last function. The last function, the symmetric difference. Symmetric difference, the last operation. The fourth one is symmetric difference. Symmetric difference. Symmetric difference. Or capsule. Symmetric difference or capsule. Example here is the value. This function it returns the elements present in first set and second set elements in present in first set and second set, but not the common element. We are present only the elements present in first set and second set, but not the common element. Indirectly, it is the reverse. Is the opposite of the intersection function. For example, S1 equal to same elements 11, 22, 33, and 44, and one more value S2 equal to 33 and 44, 55, and 66. For example, values are S1. The S1 is this is a S1 value and the S2 value. The values are 11, 22, and 22, 55, and 66. But the common elements are 33 and 44. This function returns the elements present in first set and second set, but not the common element, except the common element. But not another or except the common element, except common element. This function is present in first and second set, but not except common element. So without common elements. Okay. These elements are displayed. Without this one, these elements are not returned. Only 11 returns, 22 returns, 56, 55 returns, and 66 returns. So run the value. Print of S1 symmetric difference S2. S1 symmetric difference S2, and the value S1 symmetric difference S2, and run the values. The output here the output is only for 11, 22, 55, and 66. And the module, please observe the output 11, 22, 55, and 66. These are the set operations in Python. Up to this is clear, all of you? Thanks everyone for watching this video. Next session we will continue for the remaining part. Okay, bye. Thank you very much. Please watch, please subscribe via digitally YouTube channel. For more Python videos.